Hi all, I welcome you to this DevOps session where we are going to demonstrate three simple projects for you. So the first two are going to be fairly rudimentary, where we are going to introduce the two tools that we are going to be using for our third project. So you get an individual understanding of both of these tools before using them in integration with each other. This is going to be a three-part session, the first of which I'm going to resume with right now. But before we begin, let's discuss our agenda for today. So our first project is going to be creating a continuous integration pipeline using Jenkins. Here we're going to compile and test a piece of code which I have in my Git repository using a Jenkins pipeline. Our second project is going to help us understand another very popular tool, which is Docker. We're going to understand the Docker components through a hands-on session, by the end of which you'll learn to pull a Docker image and spin your own Docker container. And our final project is going to be a little more complex, where we are going to use the skills that we've learned through the first two projects and learn how to deploy an application using Jenkins and Docker. With that, I come to the end of my agenda. So without much ado, let's get started. So first of all, let's move forward by understanding why do we need continuous integration. So this is how a process looked like before continuous integration. Over here, you can see that there's a group of developers who are making changes to the source code that is present in a source code repository. Now, this repository could be a Git repository, a Subversion repository, etc. And when the entire source code of the application is written, it will be built by tools such as Maven. And after that, the built application will be deployed to the test server for testing, and if there is any bug in the code, developers are notified. Now this will be done with the help of a feedback loop, and if there are no bugs, then the application is deployed onto the production server for release. I know you must be thinking, it seems like a perfectly fine system. What is the problem with this? This is very textbook, right? You write the code, then you build it, then you test it, and finally you deploy it. But then let's go ahead and try to look a little closer. Let's try to analyze the flaws that were there in this process one by one, so we get a better idea of it. So this is the first problem. As you guys can see that there is a developer who's waiting for a really long time in order to get the test results, as first the entire source code of the application will be built and only then it will be deployed onto the test server for testing. It takes a lot of time, so developers have to wait for a long period of time in order to get the test results. The second problem is that since the entire source code of the application is first built and then it is tested, so if there is any bug in the code, developers have to go through the entire source code of the application. And most of you might already know that it is actually very frustrating for a developer, because he has written a code for an application which was built successfully, but in testing there were certain bugs, so he has to check the entire source code of the application in order to remove that bug, which basically takes a lot of time. So basically, locating and fixing of bugs is a very time consuming task if we take this traditional approach. And these two are the most basic problems that you face in a traditional approach. Hope you guys are with me so far. If you have any doubts, you can go ahead and leave them in the chat box. I think my team will be very happy to reply to you. So let's move forward. So now the third problem occurs at software delivery. Since the developers were actually wasting a lot of time in locating and fixing of the bugs instead of building new applications, the process is inevitably going to be really slow. Locating and fixing bugs is a very time-consuming task. And the fourth problem occurs at the feedback loop. Now, the continuous feedback related to things like build failures, test statuses, etc. was not present in this approach, due to which the developers were unaware of how their applications were doing. The feedback occurs when the entire source code of the application is built, tested, and then only the developers are notified about the bugs in the code. But as a developer, you need to be continuously notified of when your code is being pulled and built, and the moment it is built, any developer should be notified about the build status, and once it is built successfully, it is then deployed onto the test server for testing at that time. Whatever the test data says, the developer should be notified of it. Similarly, if this developer makes any commits to the source code at that time, the code should be pulled, it should be built, and then the base data should notify the developers. After that, it should be deployed to the test server for testing, and the test results should also be given to the developers. And that is what happens when I'm talking feedback. Feedback is present. So let's move forward and see how exactly continuous integration addresses these problems and helps in resolving these issues that we have discussed so far. Now, as we have discussed, there are multiple developers working on the same piece of code, and after every commit to the source code, an auto build is triggered and then it is automatically deployed on the test server. If the test results show that there is a bug in the code, then the developers only have to check the last commit made to the source code. So the advantage here is that developers actually know where the bug is present or which commit has caused the error. So they don't have to go through the entire piece of source code of the application. They just need to check that particular commit which has introduced the bug. This also increases the frequency of new software releases, and the concerned development teams are always provided with relevant feedback. So let's move forward and see what exactly is continuous integration. So continuous integration is a development practice in which the developers are required to commit changes to the source code in a shared repository several times a day or more frequently. Every commit made to the repository is then built. Now this allows the teams to detect the problems early and reduce their issues, which we discussed earlier. This entire process has continuous feedback, which also reduces the release time of each version of the application. Now, one of the ways in which this is done is through Jenkins. So Jenkins is basically a continuous integration tool, which is open source and written in Java. How it achieves continuous integration is that it does it with the help of plugins. Jenkins has well over 1,000 plugins, and that is the major reason why we are focusing on Jenkins. It is one of the most widely accepted tools for continuous integration because of its flexibility and the amount of plugins that it can support. This allows integration of the various DevOps stages that you will need to execute. It supports various development, deployment, testing technologies. For example, you get Maven, Selenium, Puppet, Ansible, Nagios, and many more. All right, now for some better understanding, let's dive straight into the demonstration. So this is what a Jenkins dashboard looks like. I have no jobs done here. So my dashboard looks like this, but if you have one or more jobs that you have already executed using Jenkins, all of those jobs along with the status are going to appear on this dashboard. So today what we are going to do, to start out a little light, we are going to build, compile and test a piece of code using a Jenkins pipeline. The code I'll be using is the one that I've acquired from Git. It's actually a fairly common piece of code, and I would encourage you to go ahead and find your own. Even so, I will leave the resources for you guys to find in the description box below. So we've already discussed Jenkins is popular because of the number of plugins it has, right? So one prerequisite of the project that we are going to further resume is the installation of a certain plugin. So for that, we have to go to Manage Jenkins. And here we're going to go down and look for this option called Manage Plugins. And here you can see all your updates. You have your Available tab. You have your Installed tab, which will show you a list of all the Jenkins plugins that you have installed before. In my case, it is all the suggested plugins that initially is suggested by Jenkins itself when you're installing Jenkins in your system. I'm running it on my Ubuntu box. So I'm going to go on Available and look for an HTML publisher, which automatically appears here. So I'm going to select it and select install without restart. Now, this is a feature of Jenkins which is going to remain consistent throughout. When a process is pending, you see a gray color ball next to the process. And once it is installed, once it is successfully run, this ball appears blue next to the name of the process. All right. So HTML publisher is now installed on our Jenkins, and you know it how? By the color of this ball. All right. So once again, just to remind you, this hands-on session around Jenkins is basically to help you understand how to compile a code that is present in GitHub. We are going to review that code and analyze the test cases present in the GitHub repository. And we're going to do all of that by creating a build pipeline using Jenkins. So let's move on to the first stage of our project. So here what we see is our developers are committing changes to the source code, and that source code is present in a shared repository. It could be anything, Subversion, Git, any repository. All right. So next what's happening here is that there is a Jenkins server and it's actually polling the source code repository at regular intervals. It's basically trying to see if any developer has made any commit to the source code. If there is a change in the source code, it will pull the code a little, prepare a build, and at the same time, the developers will be notified about the build results. Now let's go ahead and execute this much practically on our Jenkins. If you guys want to know how to install Jenkins, you can very well go ahead and check out the tutorial on our channel as well. So for this project, I'm going to be creating 3 jobs. Let's start with our first job. For that, you can either click at the create a job link on your dashboard, or on the left, you can click on new item. So I'm just going to call this compile job, and I'm going to go ahead and select a freestyle project. Now the reason I'm doing that is that a freestyle project is actually the most easy to configure. Apart from that, it's also very flexible and easy to set up. So having said that, let's go ahead and click OK. OK. So here we have our compile job. Let's just click on it and then go to configure. So now we are going to configure our job. Yes. So here I'm going to go to source code management, select Git, and here it's going to ask you to enter your Git repository. Instead of typing, I'll just go to my Git repository and just copy and paste the link. So there's this. In build, I am going to select invoke top level Maven targets. Here I'm going to select the Maven version, and in goals I'm going to write compile, right? Now you need to understand that Maven has a build lifecycle, and that build lifecycle is made up of multiple build phases. Typically, the sequence for a build phase will be first you validate the code, then you compile it, then you test it, and then you perform unit tests by using suitable unit testing framework. Then what you're going to do is you're going to package your code in a distributable format like jar or var, and then you verify it. And you can actually install any package that you want with the help of the install build phase, and then you can deploy it in the production environment for release using this. So moving on from the Maven build lifecycle, as you can see in the goals tab, what you need to do is you need to compile the code that is present in the GitHub account. So this will trigger the compile build phase of Maven. So what I'm going to do is I'm going to apply this and save it. Now to trigger the build, all you have to do is click on this build now option. Here in the bottom, you can see this little silver ball, which shows that your job is in progress. And once your job is done, it's going to turn blue, like the installation job looked like when we had installed the HTML publisher plugin. Now you can click on this progress and you can look at the console output, right? It's going to show you the various steps that it's going through. Also, for this to work, one thing I would like to give as a prerequisite tip for this to work, this is a Maven based project, so you will have to either install Maven in your system, or you have to go to the global tool configuration in Jenkins and install the Maven plugin from there. Since that's the easier approach, I have taken that approach, and I would advise you to take that approach as well. Now, while this compiles, let me just show you. All you have to do is go to Manage Jenkins, Global Tool Configuration. You go right at the bottom of this tab. Like Gretel and Ant, you will have an Add Maven button over here, which I've already used. All you have to do is click on that button and name it. Yes? All right. So again, let's go back to this. And as you can see, this has turned blue, which means this build was a success. Now we know that we have compiled the code that was present in our GitHub repository. So let's go back to the dashboard. And this blue ball, this blue status of my job says that our job was run successfully and that our GitHub code has been compiled. So moving on, let's go ahead and see what's next in this pipeline. So now that you have compiled the code, you need to test it, all right? So what Jenkins will do is that it will deploy the code onto a test server for testing. And at the same time, the developers will be notified of the test results as well. So let us again go ahead and execute this practically. So I'll go back to my Ubuntu box and I'm going to use the GitHub code. The test cases are already defined. So we are going to analyze those test cases with the help of Maven. So I'm going to go back to my Ubuntu box and create another new job. But testing would still come later. Before applying unit testing on the code that has been compiled, first what you need to do is you need to review it with the help of a PMD plugin. And that job is going to come in between your compile job and your test job. So I'm going to go ahead to new item. Let's name the review job a review job and freestyle project. Okay. Now let's go to the source code management, same old, select Git. And let's go down to build. So here again, I'm going to select invoke top level Maven targets. In order to review the code, I'm going to be using the matrix profile of Maven. So what I'm going to do is, so here we're going to type -p matrix pmd::pmd. And this is basically going to produce a PMD report, which is going to produce all the warnings and errors that are there in the code. Now there's an additional step that we're going to do in this stage. I'm going to go to the post build actions. And here I'm going to select and then we save it. So now let's go ahead and build this project. Click here, go to console output like we had done before. This should be fairly shorter than the other one. And as we can see, our code has been built successfully. Here we are doing an additional step. We are going to go to post build actions, and here we are going to publish the HTML reports, apply and save. We're going to go ahead, build it. So now finally, we're going to go ahead and test this. I'm going to go back to my dashboard. Again, I'm going to create a new item and I'm going to write test job as its name. Again, it's going to be a freestyle project. We're going to do the exact same thing as we did before. Go to build. Here again, I'm going to select invoke top level Maven targets. And in the goal, I'm going to write test. As I had mentioned before, the test script has already been written in my GitHub repository. So as I've told you earlier that the Maven build lifecycle has multiple phases, all right? One of them is a unit test. So in order to invoke that unit test, what you need to do is the Go stuff that I need to write tests, and it will invoke the build phase of the Maven build cycle, all right? So the moment I write tests here and I'll build it, I will actually analyze the test cases that are present in the GitHub account. So I'm going to go ahead and build it now. We can again go to the console output and check if it's performing unit tests on our code. And it says it's a success. Now, if I go back to my Jenkins dashboard, you can see that all three of our jobs have been successful. You can see it has been indicated by the blue color in the status sphere ball thing. We have our compile job, then we had our review job, and then we had our test job. But all of them by themselves are not yet a complete pipeline. So let's go ahead and look at what next has to be done. So we have successfully performed testing on that code. We have successfully performed unit tests on the test cases that were there on our GitHub account. Now we will move forward and see what happens after that. Now finally, what you can do is deploy that build application onto the production environment for release. So now what we're going to do is we're going to go back to our Jenkins dashboard and I'll show you how to build a pipeline. All right. So back to the Ubuntu box. So now what I'm going to do is I'm going to go ahead, click on this plus tab up top, and here you'll have these two options by default, list view and my view. For the build pipeline view, you'll have to go to manage Jenkins, again the manage plugins option, and install the build pipeline view. So I'm just going to select that. Let's call it Edureka pipeline and click on OK. So here it's pretty simple. I'm just going to go down. For select initial job, you get the option of all the three jobs. My first job is going to be the compile job, so I'm going to select that. And then number of displayed builds, let me just select 5. Then you can just go around, play around with the options, see what works for you. Just going to go ahead and click on OK. So now you can see only my compile job here, but we have to go ahead and add more jobs. So I'll again go back to my dashboard. After compile, we have review. So let's go to the options of review, configure. I'm going to go to build triggers, select build job after other projects are built. And here I'm going to use the compile job and trigger even if the build fails, just for the sake of it. But if it's actual in a real life testing environment, this definitely won't be the option that is chosen by the developers. So I'm just going to apply and save. Then I'm going to go ahead and do the same thing for the test job as well. All right, here let me go and show you the Edureka pipeline that we have just created. So now let's see what happens when we run our pipeline. So I accidentally ran this twice, but see now that we are running this pipeline, first it's going to compile our job, then it's going to pull all the code from GitHub and then compile it. Then it's going to review the job and test the job. Both of our pipelines have been run successfully. And that is how you create a very basic compile, review, and test pipeline using Jenkins. I'll take your leave for now. My name is Upasna. Thank you and have a great day.